The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. Welcome to the second part and the last part of this webinar series with Amazon and NXP. Today, for the second part, we will be telling you about how you can implement your own IoT solution and by leveraging Amazon Web Services device shadowing. And today we have Justin Mortimer on the NXP side, who will give an introduction on the MCUs. And then following him will be Anton with AWS, who will be talking about Amazon and device shadowing. But without further ado, I'll hand it off to Justin.
Thanks, Ethan. I'm really happy to be here with Anton. We're going to go through a quick agenda. Really brief introduction to the microcontroller. I don't think it needs a lot of introduction because we've already done a first part of the webinar series. Anton will take over and show a little bit of the building blocks on the core IoT services. And I think what's especially exciting about today's webinar is that Anton will be doing a webinar-based hands-on using the LPC-based IoT module with the latest baseboard. Actually, we got a bit of feedback that we needed to build a lower cost baseboard, something that's completely compatible with the original, and that's what we've done. So we created NXP, working with our partner, a baseboard that's lower cost, easy to use, and will become readily available globally. So Anton is using that latest baseboard for his hands-on session today. And of course, some overview of where to go for some more resources and getting started. So with that, let's quickly move to the next slide. Again, my name's Justin Mortimer. I'm the marketing manager, and for me, I'm just going to be covering 2 slides. So the 54,000 series, I think it's well known now in the market as NXP's Cortex M4. We have options with dual core, a lot of nice integration, but the 54018, which is the silicon that we're using for the IoT module, is really about high efficiency. It's 180 megahertz M4, helping you to perform really complex tasks in a little time. It's really why we picked this microcontroller to be working together with the AWS IoT core services, because oftentimes you really need more performance for these applications. And you also need accessibility to a lot of memory. So with 360K of RAM and then unlimited expansion via our quad SPI flash or SPIFFE, you really have a lot of flexibility in your application. Security is also a key part of your applications, and it's becoming more and more relevant and more important, and something that we hear coming up on a weekly basis. And what's really exciting about the 54018 is in the second half of this year, we're launching a completely compatible and scalable part, the 54S. And this is the most advanced security within our 54,000 series. It's providing secure boot authentication from encrypted images, RSA signature verification, root of trust embedded in the micro with anti-rollback. We have a physical and clonable function for root key using our SRAM puff. It's a silicon-based fingerprint unique to the device. Really something unique and valuable to 54S, and something that I think you're really going to benefit from as you build your IoT applications. From the Trusted Computing Group, we have something called DICE, which I think we'll have a lot more information to come as we get ready to launch this new product. And of course, we have the standard AES engine, AES 256, whereas most of our competitors are offering AES 128, random number generator, and secure hashing algorithms, SHA-2. But it's not just about the security. Obviously, BOM cost savings and reducing time to market is critical. So today we're doing some training. Obviously, there's a lot of tools and support available on our community. And we have a number of easy-to-use LQFP and BGA packages, wide operating and temperature ranges, and lots of flexible integration. So that's the introduction to the part. I'm really excited to launch the 54S with our team later this year, and we'll have a lot more information to come when we're there. But for right now, We'll switch to the next slide, and then I'll be handing it off to Anton to get started. So, we're showing here together an application block diagram. And I think the reason to do that is to give some ideas. So when Anton's going through the training, you can have some imagination as to where this might fit in a use case. These are kind of focused a little bit more on smart home control and automation, but you could equally imagine, building control and other building automation types of applications. So as an example, a door lock or smart lighting or a thermostat. All of these types of use cases require a high efficiency, high performance MCU, lots of integrated and expansion options for memory, and options for security. And so the 54018 and eventually the 54S018 will be perfect parts for you as you build your smart home control and automation applications. So here you can see in the middle, highlighted in yellow, is essentially the IoT module connected to the AWS cloud services on the left via Wi-Fi or Ethernet. And you can have, with all of the flexible integration, a wide range of sensors, whether it be from NXP or from a partner, and then also external memory via the Quad SPI interface. So just to give kind of an idea of what's possible and where people are starting to use the 54018 in their applications. But obviously many more are being used and out there in the market, but this is just an example. So we'll switch, Anton. So again, I'm really excited, and I think the training today is really going to be valuable. So just in summary here, as Anton takes over, on the next slide is kind of a visual of the control panel. So as you can imagine, a home thermostat or some other control panel using the 54018. This part, like I mentioned earlier, is available globally. We have availability through all of our global distribution channels, and the 54S0 is coming in the second half of 2018, and we'll be doing a lot of webinars and trainings as we get ready for that launch, as we update the security features in the new silicon. So again, I'm really excited for the training today. I hope all of you find it valuable, and as you have questions, please reach out to us on our community so we can help answer more of your questions or go into more detail. So with that, I'm going to hand it off to Anton, and he can go through the training material. Anton?
Good morning, good afternoon, good evening. Thank you, Justin. So this is the part 2 of this series, and today we're gonna have much less slide, and we're gonna cover much more on a hands-on session. But to very quickly recap what we've been talking last week, 2 weeks ago, is this is from AWS. This is our vision, how typical IoT applications are supposed to be built, and these are the building blocks that we are leveraging and we're giving to our customers to utilize in order to fit into their particular IoT application. So on the very left-hand side, we have the endpoints, and endpoints is typically from what how we're positioning them is typically the microcontrollers, low-power devices, often that running on a battery power. They can go into the deep sleep mode. Sometimes they can utilize the power from the main sources as well, but it's typically MCU based. To the gateway to the right is what we're positioning as a Linux based devices. There are no clear delimitation, but AWS Greengrass is primarily positioned for the embedded Linux devices. Today we're gonna be obviously talking about LPC 54018 and the newest IoT prototyping board, which is really sleek. I really love this board. I just got one last week, and I think it's really nicely designed. So, as you know, as of last year, AWS took over the open source project, the FreeRTOS open source project, and since then we've been working in order to extend the FreeRTOS. So we also contributing to the FreeRTOS kernel as many other companies, but the primary focus for the Amazon FreeRTOS is connected devices. So Amazon FreeRTOS implemented several libraries that simplifies and streamline the way the developers can build a connected application. First of all, we released the connectivity library, which simplifies the way how you connect through the MQTT with TLS 1.2 and mutual certificate authentication. So this is the only way to connect to AWS IoT broker from the low power devices on the using MQTT protocol. So it's pretty high bar from security standpoint. We also utilizing the number of secure element. Justin mentioned physical and clonable function, so we're working with that. On a slides later, I will tell a little bit about how just-in-time registration works. We also can utilize the secure element, for example, like NXP A71CH. We implemented shadow library, and we're going to be talking extensively about shadows today. Shadows is a representation, it's a virtual representation of the device state, of the physical device state in the cloud. Because as you know, these devices, they have intermittent connectivity. So again, if the device going into the deep sleep mode, it's not connected at that particular moment. So we need to have an interface how we can deterministically and predictably know in which state device has to be, and the moment the device waking up, it can readjust its state and report back. We implement the Greengrass local connectivity library. As I mentioned, this is for the local gateway, and Greengrass is not just a gateway; it's a totally new way of interacting with the devices in the field, because deploying these atomic compute units is non-intrusive, and there are no fear that my device will break with the next update, which gives developers this ability to develop very fast and try and fail fast, but without, as I said, without any fear that the next update will make device unresponsive. We also implemented over-the-air update. It's currently in beta, and we looking to release it later this year. So that's from the device side. From the cloud side, today we're going to be talking. Last week we done the overview of the entire AWS ecosystem. Today we will concentrate on AWS IoT core services. These services is kind of like a foundational building blocks for your application. So AWS IoT Core was released approximately 3 years ago, and it consists of several components. It's identity service, then very scalable message broker, rule engine, and the shadow interface. So let's take a look on each component one by one. So as I mentioned, for the devices, our primary protocol for connecting to the AWS message broker is MQTT. We only support MQTT over TLS 1.2 with mutual certificate authentication. So basically, having certificates is essential here. You can provision certificates and incorporate it in your device in a number of ways. So you can request certificates from AWS IoT identity service, and we can generate private key and certificate for you. It's good for development. It's probably not extremely secure way because to put the certificate on your device in production, and the main reason because your programming facility has to be online in order to do this. So we support another method which we call bring your own certificate. And what does it mean is you can register your own certificate authority with us, and then either manually or through just-in-time registration. So basically you can inject, you can generate the public-private keys in your HSM totally offline. Inject the private key and certificate into your final design. It can be in encrypted firmware, or it's which is even more secure, as Justin mentioned, to use either PUF technology or external secure elements. And then you can either batch register this certificate with AWS IoT broker in your particular AWS account, or utilize what we call just-in-time registration. Just-in-time registration allows you dynamically register the moment the device connecting to AWS IoT broker first time. You can dynamically apply policy and you can register the certificate. Then device reconnects, and the second time device reconnects, it can basically publish and subscribe to the topic that it been granted access to. So the AWS IoT identity service is very granular. You can pretty much you can, to the very little details, you can adjust and you can specify what your particular device or control device, like your mobile phone, can do. So the another way to connect to AWS IoT message broker is through the WebSockets or HTTPS. And those two methods, they're not using certificate authentication. They're using what we call Amazon Cognito. It's additional service that it's free of charge for our users. And what it allows you to do, it allows you to generate very short-lived credentials based on something that based on a trust from the identity provider. So it can be public identity provider, something like Amazon or Google or Twitter or Facebook, or it can be a corporate identity provider, something like SAML-based. It can be Active Directory, or it can be OAuth-based. So another component of AWS IoT Core is this very scalable message gateway or device gateway, how we call it. So majority of your devices connecting through the either MQTT or WebSockets, which means that they have a long-lived connection. Both of these protocols can implement public subscribe model, and it's really important for the IoT connected devices because you need the minimal latency that gonna be that your devices, because you want your devices to act as fast as possible to the changes that happening. So these are protocols, as I mentioned, SIGV4 and Amazon Cognita is used for WebSocket connection. SIGV4 without Cognita is used for HTTPS connection, and X509 certificate is used for during the mutual certificate authentication for the MQTT phase. Message broker implements MQTT-based routing. So if two devices subscribe to the same MQTT topic, they can obviously they can see all messages that that publish to this particular topic, and if they do have permission, they can also do the publishing to the particular topic. What is okay? We're supporting QoS 0 and QoS 1. We're not supporting QoS 2. Instead, we do have the shadow interface that's pretty much doing very similar functionality as QoS 2. So it's kind of like a deferred message delivery, but it's particularly important. The shadow interface is important because it allows you very easy way of deduplicating your messages. So MQTT topics, we have number of reserved topics. So everything that you see with the $sign AWS is a reserved topic. For us, primarily, I mean, currently it's only used for the shadow interface and lifecycle events. And as the MQTT protocol specify, you can use the wildcards when you're constructing your messages. You've seen the slide 2 weeks ago. I'm showing the relationship between the thing, certificate, and policy. As I mentioned, you can create a certificate without associating it with a thing, but from management perspective, we're strongly recommending that you will have a one-to-one relationship between the representation of your physical device in AWS which is done through the thing that incorporates registry and shadow into it. So registry values, registry attributes store static values, for example, something like serial numbers, and the shadow represent the state of the device. And certificate obviously is associated with a policy. So what in this particular case device can do. Rule engine. So having an ability devices talk to talk to each other is great, but we need something more, right? So rule engine allows you to act upon certain messages. We implemented SQL-like syntax for the rule engine, and if you implement a rule that listen to the specified MQTT topic, and for example, it see message that meets a particular condition, it can do, it can act upon it. And what does it mean? First of all, in this particular example, for example, we're querying the temperature from we're querying actually all attributes from the topic/structure, and then we only doing something when the temperature attribute is exceeding 35 degrees Celsius. And what I can do with this particular message in this case, I can, for example, republish it to another topic. I can store it as an object on S3. I can push it into the database, for example, like DynamoDB. I can also push it to AWS IoT Analytics, or pretty much like quite a big number of services. And we're going to be actually doing certain of these actions today, later on today. So this is the screenshots how typically it looks at AWS console. So in this particular case, I'm storing the values of my Hall sensor only when the reading is exceeding 4096. On the right-hand side, you can see the number of services that you can publish these messages without doing any coding. But in this particular case, for example, if you invoking Lambda function, you can pretty much do whatever you want with this message, because within the Lambda function, you can write in languages like Python or Java or JavaScript, and you can do pretty much like any type of transformation. And also you can publish it not only to AWS, you can publish to your on-prem services. So we cover a little bit about the device shadows. So how it looks in real life. So this is how it looks in the AWS console. So I do have a desired state of my device, and I have a reported state. So typically the device reporting its state, and some control unit is acting upon and controlling the state that device has to put itself in. So let's take a look on an example. For example, I have a windmill power plant, and the device, the control unit on this device, waking up and reporting the state that currently I'm in a active state. So basically, my blades are rotating. For example, I would like to put this particular windmill into the maintenance mode, and I'm applying the brakes. So I'm putting my control unit. In this case, it can be some sort of SCADA unit or just control interface. It putting my desired state that I have to apply the windmill have to apply the brakes on my rotor. So it can happen, but device might not be connected in this very particular moment, because typically these windmills, they reside in rural areas, and sometimes the cellular connectivity can be patchy, or very often you want to save on your connectivity costs, so you're not leaving device connected all the time. So the moment device waking up, it basically see that right now I have to apply the brake, so it's readjusting its state, and it's sending back to the AWS IoT to the shadow of AWS IoT that my reported state is right now basically matches my desired state. As I mentioned before, registry is where you can store the device metadata. If you have a group of devices, you can create what we call the thing type, and store the attributes that this group of devices sharing between themselves. And you can also apply the you can do some updates. You can apply some jobs. It can be firmware update. It can be some maintenance mode. You can do, let's say, rolling updates. You can do some maintenance patches, and so on. So finally, what I would like to touch here is, while the MQTT connectivity is primary means for the microcontroller to connect to AWS IoT, it's not the only way that you can connect. So we recently implemented, so right now AWS IoT Identity Service can also act as the identity provider, and the moment I have established established MQTT session with AWS IoT, I can request short-lived RESTful API credentials that I can use in order to connect to any service in AWS. As an example, it can be, for example, a signage appliance, right? That you would like to get these huge images sequentially from the S3 bucket, but you don't want to leave the S3 bucket open to the world, so you need to provide some sort of authentication there, and this is a very simple way how you can achieve that. Okay, so that's pretty much from the theory what I wanted to cover today. So let's take a look on the demo. And what we're going to be using today, we're going to be using this brand new IoT mini prototype breakout board for the LPC 54018 module, right? Because 2 weeks ago I just demonstrated how you can program module using the JTAG debugger standalone, but there are not many peripherals on this on the LPC 54018. So this little board is absolutely brilliant because it has two sockets for microelectronica clickboards. So you have access to over 400 or close to 500 right now different boards that ranges from analog to digital converter, displays, all kind of sensors. Um, um, and on the other side, you have a connector to e-ink display. Um, this display is not coming with a board, so if you're planning to use this board in your design, or you're planning to follow up the example that we've been that we will be doing today, make sure that you will purchase this display separate. So this is how the boards look like, front, back. And right now, let me connect oops. If I may ask you to go to this URL right now while I'm connecting the board. I will very quickly. So you see that the board initialized. And right now, I would be using the user button. This is the user button 0. And hopefully the demo gods will be with us today. So if all of you are ready with I mean, if you see the light bulb right now on your browser, the moment I press the button, my virtual light bulb is turning on. The moment I am releasing the button, it's turning off. So it's all implemented through the shadow interface that's running in on a back of AWS IoT. So we can take a look how it's actually implemented. So I will subscribe to all the topics, and now you will be able to see that when I'm pressing the button, a lot of messages is actually going on there. So what's happening on the back is that I'm updating the shadow of this particular device. So this is the shadow of the thing that's called LTC-SF part 2, right? And the moment I release the button, it's basically submitting this value. And I'm also republishing this to no, this is not so what I'm doing in this particular case, I don't know if you can actually see this, but this is the SQL statement that I'm actually executing. So when my button when I'm pressing the button, the microcontroller sends a message that's saying my button attribute in my JSON equal to this string value pressed. And I'm translating, in this particular case, I'm translating this to the light bulb value of 100%. I'm turning the light bulb on. When I'm releasing the button, the same thing, the same message sent to AWS IoT that my button released, and I'm basically I'm passing the value 0 to this very particular attribute. So I'm changing the state of the different thing, and this thing in my case is actually virtual thing. It's basically it's a Cognito. It's a single page application with a Cognito user pool that associated with it that allows you to connect to AWS IoT broker securely, because you can, if you paranoid or if you security conscious, you can take a look on the source code of that particular single page application. You will see that I'm specifying Cognito user pool there, but there are no username and password hard coded in it. So we pretty much connecting as unauthenticated Cognito pool, and we granted this short-lived token, granting us a permission to read certain values from the from this particular topics. Okay, so this is this is the demo in short, how we basically building it, and where's the source code, and how we programming this particular interface. So I hope you already have the MCU Espresso downloaded. You will need the latest version, because for some reason on the 10.1 this application was not compiling. You also will need obviously the SDK for the LPC 54018 to be installed, and it has to be the latest version, which is 2.4.0. So right now, let's go ahead and yep. I will need the URL for my source code. So I download the source code for this particular application. I also would like to download, to do one more download, actually to clone one more repo. And this is to clone the standard Amazon FreeRTOS repo. As I mentioned before, as I mentioned a couple of weeks ago, the easiest way to provision certificates, thing, and policy into AWS IoT, and to generate the two header files that is important, that is crucial for this particular for compilation, right? You need to the easiest way is basically to utilize the tools that comes with the Amazon FreeRTOS. Okay, meanwhile it's downloading. Let's go to the MCUs Espresso and open project. So, and you need to open the this particular project, IoT base plus AWS. Click finish. Expand your source. Expand the Amazon FreeRTOS, and within include, as you can see, for example, right now we do have this AWS credentials header file, but we don't have our Wi-Fi specified, and we don't have the AWS credentials keys at all. So what are we doing? The easiest way, we're going to Amazon FreeRTOS demos, common tools, opening this file, and we specify. We can, for example, specify the LPC 54018 part 2. And as Wi-Fi security, we're specifying Wi-Fi WK2. Okay, looks good. One prerequisite though, you will need to install the AWS CLI. It's very easy to do if on Macintosh or Windows. It's pretty much like if you have the Python, Python installed, you can do pip install AWS CLI. I will not be doing it because I already have it. And then you will need to say AWS configure, and AWS configure will allow you to specify your access key and your secret key, and you can find those in your IAM So for example, in this case, I can create a new access key for myself. Make sure that you will get it right away, especially the security portion of it, because we're not storing it. It's only stored. It's only stored in the for the time of provisioning. Okay. So in order to verify if your AWS command line working, you can say something like describe endpoint. And in this case, this is my endpoint, and this is what I will need to specify over here. But through the provisioning script, so the moment we will create this configure JSON, the command that you need to know is Python setup AWS PY setup. So let's verify if our new if our new thing was created. Okay, so fantastic, we have it. Right now, the shadow for this device is gonna be 0 because device never connected. You can also explore the relationship. For example, this is my certificate, right? And this is the policy for my certificates. So as you can see, this is pretty permissive policy. It allows me to connect, publish, or subscribe to pretty much all topics. You can very easily edit this and specify the only topics you would like this device to be able to connect. Alternatively, if you don't want to do it through the console, sometimes it's a little bit more intuitive, especially when you're beginning working with AWS IoT. So console gives you kind of the overview, but you certainly can use the command line. So you can say AWS IoT list things, right? And I mean, I can do something like grep LPC. Right, so this is one of the things that was provisioning for me, and this is what we done just now. Okay, so we do have certificates and thing provisions right now. So we can go back. We can check which files changed, right? So in this particular case, we also created these 2 files, and we need to find them right now, and we need to copy them into our LPC project. So let's go here. Common include, and here's 2 of my files that I need to copy to my project. I can do it as a simple drag and drop. I want to copy files. And obviously, I want to override the AWS client credential file there. Let's build our project. So project build. Let's use our debug configuration. And it's at the first breakpoint. So let me run the configuration here. I can double check what's going on with my board. Okay, so we published to the shadow, and let me bring the e-ink screen. Okay, it looks okay. So now please pay attention to this string. What I will do, I will be interacting with the shadow of this device. So this is what we seen before. The shadow was empty. And right now I change the desired state of this shadow to, for example, Amazon FreeRTOS. I click save. And look what's happening with the screen. It's ink with the 3 colors, so obviously it's doing quite a lot of bubbling there because it's a different particles that bubble up to the screen. But as you can see, Amazon FreeRTOS. So essentially, this is how you interacting with the shadow. As you can see, for example, my button is my button is released right now. When I'm pressing, it's pressed and then released again. That's pretty much it. I hope you enjoyed this little demonstration. If you're interested to follow these steps on your own, this is the GitHub repo for today's demo. It's been developed by Embedded Artists, the same company that developed the board, the breakout board. There are a few things that I would do differently in terms of the coding. So hopefully for the next next time we will present better updated demo, because right now there are a few quirks, and the quirks are following. currently device updating desired and reported state at the same time. In all reality, it's only need to update its its reported state, and your control interface is updating the desired state. So that's all from me. Back to Justin and Ethan. Hello?
Hi, Anton. Thank you. It was a great hands-on. So we actually don't have any questions right now, but we are over time. So, like Justin said before, we do have the community page, which we really encourage you to get involved in. We're very active on there, and we would love to help you answer any questions and give more information.
Yeah, and Anton, I want to thank you for taking the time to spend with everybody. I really appreciate the technical webinar you did and the approach with the hands-on. And I encourage everybody, definitely reach out on our respective communities, and we're really looking forward to getting more boards and more content out to the market. And we've already seen a lot of great applications, so definitely share what you're working on, and look forward to the second half this year as we launch the 54S with all the embedded security that I mentioned earlier. But thanks again.
Thanks, everyone.
Thank you, everybody.
Just a quick reminder, keep a lookout for the follow-up email. It'll have the recording and the presentation material. So that should either go out, that'll probably go out tomorrow. So keep a lookout for that. But again, thank you for joining this webinar series, and we'll see you later.